Hello, everyone. Welcome to this session of Virtual Open Day for EIT. So I'm going to actually present a lecturer's insight section of this particular virtual Open Day. So it will start now. And let me introduce myself. I'm Dr. Milind Siddhpura. I'm actually the course coordinator and a lecturer in mechanical engineering at EIT. And a little bit about myself. Let me go to the next slide. So I got a few years of experience as an academic in some of the Australian and overseas universities, and I actually did my PhD in mechanical engineering from UWA, which is one of the local university here, and got some awards and scholarships due to my publications in international journals. And currently I'm working as a course coordinator and a lecturer in mechanical engineering, but I also, obviously, it's quite multidisciplinary. So I actually get to interact with all the disciplines, and that's the reason I'm actually presenting on behalf of all of the other course coordinators of other disciplines like civil engineering, civil and structural engineering, electrical engineering, industrial automation, and obviously my discipline, which is mechanical engineering. So I'm actually responsible for developing and maintaining highest quality of the courses, including the bachelor's, master's, and doctorate of engineering at EIT. So that's just a little bit about me. I actually live in Perth in Western Australia and thoroughly enjoy the local warm weather. So let me go to the next slide. To close this. Yep, I hope you can see the next slide. And so let's look at the agenda in my particular section. So I'll be looking at mechanical engineering. I'll be explaining all of these disciplines one by one, not only just the courses, but I'll also go through what are the career perspectives for these different courses. For example, mechanical, civil and structural, electrical engineering, industrial automation, and we have some of these specialty courses, which I'll be discussing as well. And at the end, you would have some time for questions and answers. So with that, let's start. So first of all, my favorite stream is mechanical engineering, obviously, because I'm a mechanical engineer myself with a PhD in it as well. And it is actually called as an evergreen branch of engineering. Why? Because mechanical engineers can virtually, literally work in any space, whether it's mining or marine or aerospace, or any sort of industries. Even in the power plants, the mechanical engineers are needed, and that's the reason I'm actually liking this branch, which I actually coordinate myself as well. So let's look at what's inside the mechanical engineering courses. So let me go to the next one. I think it takes some time to click the slides. I have clicked it twice already. It's not clicking to the next slide. Now it is. Okay, good. So what is mechanical engineering? So it's actually a very broad discipline, as I just mentioned. People can work in a variety of areas and industries. So it is a discipline which actually applies basic principles of engineering for the design, manufacturing, operation, and maintenance of a variety of machines and parts. So here you can see some pictures, right? So looking at these pictures, can you identify any of the components or machines which I have displayed here on the slide? So, for example, what is this? It's internal mechanism of a wristwatch. This is a huge mining truck or dozer. This is an aircraft, an F1 racing car. Here you can see a lawnmower, a spacecraft, a shoeing machine, and an excavator, right? An hydraulic excavator. So all of these machines, so whatever you see around, you just see around yourself, anything which is moving is actually designed and maybe built by a mechanical engineer. So mechanical engineers are responsible for any moving items which you see around you. So this is just the basic of what mechanical engineers normally can design or build or maintain or operate. And going to the next slide is what are the potential job areas mechanical engineers usually work in. So here again, you can see some pictures here, right? So There are a variety of industries, and all of these are actually listed here. As you can see, computer-aided design, CAD, is a vast area because it can be applied anywhere. Any CAD drafter or designer could actually design literally anything which you see around you, including computer parts, electronic parts, mining machines, or big rigs, or some of the oil and gas equipment. All of these we could actually design under the area of CAD. Manufacturing engineering, obviously anything needs to be made after it's designed. So in the manufacturing sector, many mechanical engineers are responsible for precisely creating these components and machines. Automobile engineering, it is also a sub-discipline of mechanical, in which engineers actually build cars and vehicles, not only cars, but the trucks and lots of agricultural equipment as well. So aerospace engineering, so if you're talking about NASA or any of other spacecraft agencies or companies, they actually need mechanical engineers as well. One of the other big field is air conditioning, so that they call it HVAC, heating, ventilation, and air conditioning. These are actually totally coming under mechanical engineering discipline. Materials engineering, how to select appropriate materials, and power plant engineering. These are responsible for producing electricity. It could be hydropower plant, coal power plant, nuclear power plant, and maybe hydrogen power plant would be designed and maybe manufactured by mechanical engineers in some way. Then mechatronics and robotics is also part of mechanical engineering. And I talked about agricultural engineering. It's a huge area as well in itself. Industrial engineering, which looks after the productivity and precision and accuracy of the machines which we create. And again, as you can see, mining and oil and gas, these are the two giant sub-disciplines of mechanical engineering. In a way, mechanical engineers are employed over here. And then we have marine engineering. So here you can see some pictures, right? Here some automation kind of mechatronics laboratory, marine and oil and gas. Here you can see a machine in mining, yeah, and some of the other industry, the CAD, application of CAD in mechanical engineering to produce parts. Here is some spacecraft, a huge refinery, and a car assembly line. All of these are pictures which shows you potential job areas in which mechanical engineers could work. And it could be starting, if you studied a graduate, a bachelor's degree or a master's degree, you could be starting as a graduate engineer, yep, or a graduate assistant engineer, but then you work your way up and you can specialize in certain area depending on what you like and what you have opportunity coming in. So that's about that. And moving forward. The next one, just give me a sec. The slide takes a couple of seconds to change. I hope it didn't change 2 slides now. All right. So trending topics. So what are trending topics in mechanical engineering at the moment? Because the industries are evolving at such a faster rate. Industrial Revolution 1, 2, and 3, and now Industry Revolution 4.0 is taking place, and you could see trending topics is obviously CAD is one of the major trending topic at the moment. So computer-aided design and computer-aided manufacturing are actually covered in our existing courses and some of the subjects and units which you see here. So engineering design and drawing at a bachelor's level, mechanical design, they cover CAD extensively. And then we have at a master's level, CAD and CAM is also covered. And obviously bachelor's and master's final year project also covers CAD and CAM. So CAM, for example, computer-aided manufacturing is covered in at a bachelor's level and also at a master's level. Another hot area right now is a finite element analysis, because when you produce something like in terms of design, if you are designing and modeling 3D models of a component of a machine, you need to know if it could endure the force requirement. So if it is working under a machine or inside a giant assembly, can it really take the stress and not break? You can practically check it using FEA analysis, finite element analysis, and using that you can predict whether under what force, what situations, what type of forces it could endure. and then you can start manufacturing it. So that's covered at a bachelor's level and also at a master's level as well. And the next one is CFD, which is computational fluid dynamics area, is gigantic itself as well, because there are a number of companies around the world which are actually providing CFD solutions. So that's being taught at a bachelor's and also at a master's level as well. And the last is aerospace and aerodynamics applications. So that's covered at a master's level in one of the courses here. So I hope that helps. Going to the next one. All right. Hopefully it changes. Feel free to send your questions in. If you have any comments, questions while I'm actually speaking, that would be great. I could try to incorporate in my talk, or maybe at the end in the Q&A. So I just talked about some of the hot areas in mechanical engineering, right? So I was talking about CAD/CAM. So CAD/CAM is an area which is taught literally as per the industry standards. We're not talking about theory. So when I say we teach CAD and CAM in any of the courses, we actually teach you industry software. For example, SolidWorks is a current software which we use to teach you the individual part modeling, drawing, 3D model building. Everything is actually covered in CAD and CAM. And this is the example of FEM and FEA, which is finite element analysis. So structural components which you actually made in SolidWorks, they can be transported to ANSYS or some other relevant analysis software, and they are put under a certain load, certain boundary conditions, and you can see where the stresses are higher, where stresses are lower, and you can actually play with the dimensions and boundary conditions to make sure your components, your machines don't fail under that type of force or stress. So that's FEM, FEA. Then we have advanced fluid mechanics or CFD analysis. So if you have on an oil rig or a refinery, if you have a huge pipeline you want to design and you like to see if certain amount of crude oil is passing through that pipeline, and if it could withstand that type of temperature, pressure, and flow requirement of the crude oil, you could actually do simulation using ANSYS Fluent, and that is also taught in one of the courses, actually two of the courses as well. Then comes the aerodynamics, which includes vehicles, aircrafts, and spacecrafts. So again, the ANSYS Fluent, we have a capability, and we have actually people, professional people who are working in the industry, teaching you the software, not just someone, novice teaching you the software. We have experts coming in or streaming into your classroom from Canada, from Spain, from USA, from New Zealand. So there is no geographical barrier with EIT. So lecturers are actually streaming in, which are real experts in the field rather than someone just knows some theoretical stuff. So that's about that. Let's go to the next one. Just take some seconds. Alrighty, so next one is civil engineering. So civil engineering, civil and structural engineering is another one. And let's go and see what's in it. So what is civil engineering or civil and structural engineering? It's again a very broad discipline. Yeah, very broad discipline, and you can see lots of areas covered here. And it is one of the oldest professions. Back in the days when people used to say I'm an engineer, people used to always believe that you must be building some buildings or bridges or structures like dams and stuff like that. So transport is one of the sub-discipline of civil and structural engineering. And obviously structural itself, it's a discipline which designs and analyzes the structures. Environmental engineering is part of civil. Obviously construction is one of the main, where you can see lots of construction activities going on around the world. And someone has just commented about railway engineering. So railway is actually part of civil structural course, and I will be talking about that particular railway engineering stream at the end. So please wait for a few minutes. Geotechnical is all about, making sure your structure is geotechnically sound, or, due to earthquakes and stuff, it could withstand all sort of stresses and forces. Water resources, building the dams and canals and lots of, weirs. This is all covered under civil and structural engineering courses. So moving forward. Yep. So here you can see what are the potential job areas in civil and structural engineering. So in this one, you have structural engineering as one of the key areas, or someone who has completed a civil structural engineering bachelor's or master's could start working as a structural engineer. Yeah. And they could work as a construction project manager, supervisor, site engineer, design or transport engineer. Surveying is in itself a separate branch. Every single building project, construction project needs surveyors, geotechnical engineers, and obviously CAD drafters and designers. All of these are required in civil engineering. So if you are working in the civil engineering company, civil and structural engineering company, you might be involved in planning or design any transportation of fluids, or designing some structures on computers, using a range of computer softwares to do some detailed design and analysis of those structures, graphical representations, which means plans and drawings and 3D models, liaising with customers and architects. And you could be also working in a laboratory, doing some physical tests on the materials, some type of concrete blocks you would like to do compressive or tensile testing. You could do so in this laboratory environment. So these are all potential job areas in civil and structural engineering. So moving to the next. All right, some of the trending topics in civil and structural engineering, which you can see here. So digital engineering, which is obviously most of the engineering branches and disciplines, they are actually shifting their work, the manual drawing and some of these analysis work, into digital space. And some of these cities, big cities like Singapore, has a digital twin of the entire city. That's possible due to digital engineering. So you think about a location, and you could actually create a total digital twin of the entire infrastructure of the city into digital space. So digital engineering is a big one. Next one is FEA, which is finite element analysis. And that's again like mechanical. You could actually analyze various joints, structures, beam, columns, and trusses under FEA software. And another trending topic right now is sustainability, because United Nations actually developed certain sustainability goals and some of the countries also started following them. And that's actually covered under civil and structural engineering to make your construction and building more sustainable. And finally, building information modeling, which is known as BIM. BIM is also very, very hot area at the moment. You could actually, look at not the structural part of it, but also the environmental impact of a building as well in the BIM software. So these are all the trending topics of civil and structural. Let's go to the next one. Yeah, so let's look at delivery of these trending topics. How do we cover this in our courses? So trending topic, for example, if we talk about BIM, building information modeling, that's actually covered in our Bachelor of Science in Civil Structural Engineering, BCS. And obviously there are other structural analysis software like, Abacus or Space Gas. That's actually covered under Master of Engineering, Civil and Structural, known as MCS. And moving forward. Next one we have is a Master of Engineering, Civil and Structural Engineering. So these are various photos of the real industry software which we teach them, Space Gas. Even Microsoft Excel is used to do very high level of engineering analysis. some of my friends working in the industry at a senior level and doing design and analysis, they use Microsoft Excel a lot. So that's another powerful tool. Then you can see a screenshot of different softwares like Abacus and SpaceGas, which are used in a variety of courses, which you can see here. It's a master's in civil and structural, bachelor of science in civil and structural, advanced diploma in civil and structural engineering. They also covered this Excel, and master of civil, and also the doctorate of engineering. So we offer doctorate of engineering course in almost all the disciplines, and they also use a variety of softwares. Depending on the thesis topic, they would take the software on board, but it depends. So that's that. All right, talking about the next discipline, which is electrical engineering. And let's see what's in electrical engineering. Obviously, most of you would be using quite a few electrical devices nowadays, and electrical engineering is a discipline which is concerned with study, design, application of all of this equipment, electrical equipment, devices, systems which use electricity, electronics, or some sort of electromagnetism. So here you can see some pictures of electric motor, an electric train, a mobile device, your computer, and lots of electronic gadgets are there, right? So all of these are needing electricity to run, and your electrical engineering is based on that. So if you are a graduate electrical engineer, what area you would be working in? So let's look at that. And so you could be involved in electrical system planning, design, development, and so some sort of power supply, distribution and transmission, electrical commissioning, renewable energy, electrical instrumentation and control. You could be doing some type of electronic research. Obviously running, operating, maintaining all of these devices and transformers and your substations and power stations. Electrical project management and business development is another area. You could be working under radio and television broadcasting of some of these things. Mining also use some electrical engineers, advanced automation and robotic system, and also space defense systems. All of these equipment and all of these subdisciplines and areas, you could work as an electrical engineer. So I hope this helps. Going to the next. Just waiting for slides to turn. All right, so some of the trending topics of electrical engineering. You can see here a layout or schematic showing you the power infrastructure. So how power is produced in a power plant, transmitted through the poles, distributed, and their electricity is consumed at a location, which could be a house or a factory where it is being consumed. So, and then there is a communication infrastructure with the mobile devices and the mobile networks. You have entire, communication infrastructure also is a hot area for electrical engineers. And data and machine learning is also trending in electrical engineering as well. You would see that, when you produce electricity, there are two ways of producing it. Either non-renewable energy, which is kind of a traditional part, in traditional way, oil is used, coal is used, nuclear energy, and some natural gas is used to actually produce energy. But that could be turned into renewable energy, where you are using wind, hydropower, solar, geothermal, and biomass to produce your electricity. So here you can see some picture of renewable energy area, wind tunnels, the wind farm. Then you have solar farm and some geothermal energy, solar panels. And so the goal is basically to maintain sustainability in whatever you do in engineering space. So I hope that helps going forward. Let's talk about the next one, which is industrial automation engineering. So industrial automation engineering is the fourth discipline which we offer, the fourth main discipline. We also offer some of the other subdisciplinary areas. But industrial automation basically is use of a variety of control systems, including robots, computers, and some of the technology to handle the processes and the machinery autonomously. So people are talking about smart industries, right? So in a smart industry, the industry is capable of manufacturing something, or maybe assembling something. Maybe a bag of chips which you are eating is actually a fully automated plant could actually make it. There are various robots and cylinders, hydraulic pneumatic cylinders are operated in a way with a programmable logic controller, and you just put the potatoes in, start the button, and it would start slicing the potatoes, frying the potatoes, and then putting them in a bag, sealing the bag, putting in the box, and dispatch it in a truck. So the chip industry, any beverage industry are like that. So there is minimum human intervention, and that type of autonomous industries are called smart industries, and they are coming under the field called industrial automation. So this is a picture of that, and I'd like to talk about different potential job areas. If you are a graduate with industrial automation, you could be working in the field called mechatronics or robotics, industrial engineering, control engineering. You are part of the control engineering team, electrical process engineering. You will be looking into industrial communication systems, oil and gas instrumentations, and IT, OT security convergence. So here you can see some pictures of a car assembly line, and lots of robots are actually manufacturing your car's chassis, the body. They paint it, they test it, and they make the car. Maybe 3 minutes. Every 3 minutes, a car is being manufactured. Obviously, humans are working along with the machines, but the main area is that most of these items are automated fully, and that's possible due to industrial automation. So that's that. Let's move to the next slide. So, okay, this one is showing you 4 pillars or trends in industrial automation. So the first picture, what you can see here, is of PLC. So programmable logic controller are actually heavily used in industrial automation or smart factories. So this is actually covered in our Masters of Industrial Automation. There are some additional smaller courses called graduate certificates. So graduate certificates in industrial automation and graduate certificate in PLC. They actually cover PLC, how to actually write the codes, ladder logic, and then you can control and you can build the circuits without needing any physical electrical circuits to it. And you can have number of logics employed into your control system. So that's PLC. Then you can talk about second area is SCADA. So SCADA is also covered in your Bachelor of Science in Industrial Automation, BIA. Here you can see some screenshots of SCADA software being taught to students and so on. So let's move forward. And these 2 pictures here are actually showing you other 2 trends, which is about PID controllers. So even though they are very traditional type of controller, PID controllers are still being employed in the industry, in industrial automation setup. And you could learn about PID controllers, like closed loop systems. How can you manage to automate the process, to manage certain process variables? That's done by PID controllers, and that's actually being taught in advanced diploma in industrial automation as well. So that's that. And then the last field for industrial automation is industrial IoT system and communication setup. And you could see the picture of a particular setup of an IoT system, which is taught at a professional certificate level as well. So that's all covered. And these are all the trending areas. All right. Next one we have is a very specialized course. So I actually briefed you about the 4 main courses, which was mechanical, civil and structural, electrical, and industrial automation. I hope it makes sense to you. Feel free to send your questions through the chat box. And because I'm monitoring that as well, I can answer those questions right now and maybe at the end, depending on what type of questions you ask. And so the next area I'm going to talk about is safety, risk, and reliability engineering. It's a huge area because it actually is a quite multidisciplinary area. And if you are working in any industry, it doesn't matter in what capacity, what roles, you need to ensure enough safety and risk analysis and reliability measurements are in place. So these courses are also quite popular at EIT. So let me actually show you what's in it. So what is safety, risk, and reliability? Because if you are working as an engineer or a technician or a technologist in an industry, in any industry, it could be a refinery, a mining plant, mining field, or it could be an air conditioning system, or a construction industry, or electrical safety, or power generation. All of these machines and plants, they need to have some inbuilt safety. And in some of the terms, they call it fail-safe design. How can you design something which is fail-safe, which doesn't fail? But if there is fail, there is no knock-on effect on each other. So all of this is covered in the area called safety, risk, and reliability. So you have to, produce plant safety, occupational health and safety plans in place, reliable designs which normally don't fail, and what are the acceptable risk. Those are the focus of this practical application of engineering. And there are a wide range of techniques available to assess the risk of a plant, risk of a process, and how you can create more reliable infrastructure. And all of this is actually covered, and that is actually covered, all of this in safety, risk, and reliability. So let me actually show you what's the part of it. If you are graduate with safety, risk, and reliability, you could literally go into any field, any industry, and apply for a job. It doesn't matter, mining, marine, or manufacturing. You could be working there as a project manager, principal risk analyst, work environment coordinator, safety reliability engineer, head of safety and risk, or it could be, say, senior safety, or maybe a graduate safety engineer in a company. So these are all of the job roles which you could potentially apply for and get into. So some of the content delivery examples I'm showing you now under the safety, risk, and reliability. So they cover extensively IEC standards for safety life cycle. And you can see, I'm not going to go into the technical details because I know you are all still trying to learn about engineering courses, and this is technically too heavy. But some of the IEC life cycle includes analysis, realization, and operation. It's all, the entire safety life cycle is covered in this course. It also covers international safety standards under IEC, and also instrumented system safety, which is SIS, is also covered in this. So that's that. Going forward. So talking about the next course, I think there was a comment about the railway part, the railway subdiscipline of civil. Yes, we actually cover, civil railway infrastructure course as well. There is a master's course and there is also graduate certificate. So let's talk about that. So what is a railway engineering field? It's again a very multidisciplinary field. Obviously, what EIT offers is more civil structural focused, but even if you like to know a little bit about the mechanical side of it, it's also covered within the course as well. So as listed here, railway engineering is a discipline which deals with the design, the construction, operation, and maintenance of your railway tracks and a variety of railway systems. So here you can see some pictures, right? Railways run on a railway track. So railway track is a major part of their infrastructure, and obviously the actual railway engines, their bogies, and signaling system, all of this is covered here as well. So let's go forward from here. Yeah, what are the potential job areas in railway engineering? So railway infrastructure, if you are graduate with graduate diploma or with graduate certificate, you could work in the railway industry as a project engineer, as an asset manager, project engineer and project manager, a purvey engineer, senior civil engineer or rail project engineer. You could be simply working on the tracks, because tracks itself has a huge infrastructure. So senior track designer, track engineer, safety assurance engineer, or chief estimator, estimating how many sleepers and railway tracks you need to lay between two cities. So it could be like that. Here you can see some pictures of people working on railway industry. So that's that. All righty. So let's look at some of the trending topics in railway engineering or railway infrastructure. So some of the trending topics right now are practical railway operation and their simulation. And there is a specialized software called IFBS, which is actually part of the course itself. Also being taught local regulations and standards. Now, obviously, EIT offers international courses, or some of the regulations could be of certain country, but we try to cover the regulations and standards in a way it covers all around the world. So, but you have to, maybe do a little more training after that. But more or less, more of the principles are covered in the standards, which we covered in the courses. Digital engineering and asset management for railway is also covered in there. So in the next slide, I'll be showing you what are the types of software and what are the technologies which we are teaching in railway infrastructure, civil and structural course. So here you can see some delivery of trending topics which are covered here. So railway asset management is a huge area itself, because lots of assets are there which are across the countries usually in a railway infrastructure. Railway timetabling it looks like it's just a timetabling of railway or trains, right? But it's not. It's really, really complex process. There are dedicated software being used for railway timetabling, and people needs to be trained in that. So fortunately in this course, you can get trained into railway timetabling. And the next one is railway stress analysis. Your stress analysis of anything, a very basic one would be the actual track cross section. How would you design it? How would you manufacture it? And how would you actually install it? And after you install it, how would you maintain your tracks? That's an ongoing process. So you'll be learning everything about railway tracks within your course. Signaling is another one. So signaling seems like normal, signaling system, red, yellow, green. But it's much more complex than you would think in a signaling. Lots of electronics, lots of project management goes, and lots of technologies being used. So signaling is actually taught within the course as well. And rail installation requirements are covered, totally covered. You know how particular segment of a particular railway component is installed in the assembly. And lastly, wheel rail interaction. Now that's kind of a totally simulation based area where you like to know how the railway tracks are being worn due to the loads, what type of loads. So you could actually run some software simulations to learn about in what type of loading condition, whether it's a passenger train or a goods train or some refinery train bringing crude oil. And you can actually predict when the tracks are lightly worn, heavily worn, and you can decide the lifespan of it. And you can, arrange the scheduled maintenance or installation, reinstallation, or replacement of the component. So all of this is possible because of these trending topics thoroughly covered in railway engineering.